On December 24, 1968, they observed Earth rising over the moon's horizon and hurried to take a picture. Earthrise remains one of the most striking photographs ever taken. It shows Earth's rolling white clouds and blue ocean over the moon's lifeless gray surface. A curving shadow across the planet separates night from day. The picture also clear, present, and plainly spherical, shaped in a way that had never been shown before. Human discovery that Earth is a sphere thousands of years ago, long before they rocket into space. How people prove this and how we can confirm it for ourselves is an interesting opportunity to put our science skills to work. Earth and the scientific method. Curiosity is a powerful human instinct that has led the inquisitive thinker to explore questions, big and small, about the world we live in. Scientists may be the most curious of them all. Understanding the natural world is one of the main axios in science. Our planet might be considered the first laboratory because as people explored the land and seas, they naturally wanted to learn more about the shape where they live. From surface, Earth may seem flat. Long ago, individuals noted evidence that suggested otherwise. They began no wonder the real shape of the planet was shown. If their investigation failed to produce the answer they expected, they adjusted their idea and tried again. That is a basic description of the scientific method, which is the systematic process of posing questions or hypotheses, then testing them to determine whether they are accurate. The goal is to discover a result that remains true no matter how many times the experience is repeated, and no matter who does the experiment. The scientific method is a scientific greatest tool. It a proof of its round. Evidence of the ancients. Today, aircraft, weather balloons, and spacecraft can confirm the Earth shape from high in the sky. Before such technology, though, how did thinkers figure out that Earth is round? Sailors were quite possibly to the first to wonder about Earth's shape, even though people on the shore must have noticed that ships sailing away from them didn't just get smaller. Instead, the ships seemed to disappear from the bottom to top, as if they were sinking. The way ships disappeared was a result of limits of human vision. Climbing a tall hill would make the whole ship visible again. It was evidence of a round Earth. Earth's curvature was grudgingly hiding the ship from the observer as it traveled around the horizon. Knowing Earth's shape was so vital to sailor success and survival. The storms used for navigating long distance followed pattern that can all be explained by Earth being a sphere. Rejecting that reality was a recipe for getting lost. Ancient Greece was famed for its philosophers as well as the expertise of its sailors. At that time, philosopher was a term for someone who studied questions related to science and other subjects. Some Greek philosophers were curious about the Earth's shape, though through careful observation and thought testing, they searched the clue to the answer. Aristotle was a genius among the ancient Greeks. In about 350 BC, he observed that constellations are visible as one travels south or north. The Big Dipper is a set of 7 stars that look like a ladder. It always visible at latitude up to 41 degrees north or higher, the northern hemisphere. However, if you travel below 25 degrees south in the southern hemisphere, you won't see it at all. This different view are logical if one is traveling along the surface of the sphere, but don't make sense if one is traveling on a flat plane. Elsewhere also pointed to lunar eclipse and evidence of Earth shape. During lunar eclipse, Earth's shadows on the moon face is always curved. It's viewed high in the sky or choose to horizon again. The logical conclusion is that Earth is a spherical. About 100 years later, another Greek philosopher used a different observation to test the round of hypothesis. He used sunshine, shadows, sun measurements, and geometry. People living in a city in southern Egypt had reported that at noon on the June 20, the sun was directly overhead. They could tell that the sun was precisely noon above the town because it was only day and the sun shone straight down a specific deep well. However, on the exact same date and the same time, Eratosthenes observed something different in the Alexandria, Egypt, about 600 kilometers directly north of Sin. There is a sunless telecast, a shadow at a slight angle. In other words, where the sun is shining straight down the sea, it was not shining down straight to Alexandria. 800 kilometers may seem like a long distance, but compared to the distance from the Earth to the Sun, it's not far at all. If the world were flat, the sun, because of the great distance, would have appeared directly above cities. Eratosthenes is sure that shadows were different because Earth was a sphere. Eratosthenes took his investigation further. Based on the angle of the sun's shadow and distance between Sin and Alexandria, he used geometry to calculate circumstances of distance around Earth. I first think his calculation was fairly close to the real circumstances, about 40,075 kilometers. Not bad for someone without high-tech tools living more than 2,300 years ago. Why Earth is round? Curious mind, aided by the scientific method, prove Earth is round. But Earth is not only object in space with this characteristic. Other planets, the Sun and the Moon, most other large space objects are also round. We can easily see through the telescope, even with just our eyes. Why is that? The answer is gravity. Every physical thing has mass. From a huge planet to a grain of sand, mass naturally attaches other mass by the means of gravity. The more force is exerted, this force is unnoticeable between small objects of mass, therefore a great deal of gravity. The gravity pulls inward toward the center from every direction. It is so strong that it crushes or compacts a planet or sun into a spherical shape, just as you might crush a snowball. Most large objects in the space end up as a sphere because each point on the surface of a sphere is close to the center as it can get. Not all space objects have the necessary amount of mass to be forced into a spherical shape, though asteroids, for example, are smaller than planets and moons. Only a few known asteroids have enough mass and gravity to be spheres. Practical proof. The gravity the gravity that keeps our feet on the ground, also a function of Earth's mass. If we drop a rock, it falls down. Wherever we stand on Earth's surface, the rock will be pushed toward the center of the planet. Gravitational force also holds the moon, the Earth's orbit, and kept the Earth in our entire solar system orbit around the sun. Earth's spherical shape not just an interesting fact, it also affects how we live, build, and move. Just making a phone call provides practical proof of Earth's shape. Imagine it midday in London, the capital of England. You call a friend in Wellington, the capital of New Zealand. Your friend asks, "Do you know what time is it?" It's the middle of the night. Why, 12-hour difference. London and Wellington are on the opposite side of the globe, where the sun shines on one half of all the planet, the other half is in shadow. Earth is divided in zones to help humans in distant places manage time, avoiding disruptive phone calls. Engineers on big projects also must take the Earth's shape into account. Consider Venezuela's narrow bridges in New York City, which was completed in 1964. This bridge is suspended on two giant 211-meter towers that are 1,298 meters apart from each other. The designer didn't make the tower perfectly parallel, though the tops are actually 41.3 millimeters farther than the bases. Why? To make bridges just as stable as possible, the builder had to adjust Earth's curvature. Every day, airline pilots must navigate round Earth, look at a flat map of the world, and find New York City will reach Spain. The two cities are almost exactly east or west of each other. Flying from New York, you might think the shortest distance to Madrid, if directly is across the Atlantic Ocean. However, if you look out on your window during the flight, you might see the ice on Arctic Ocean below. Why? The aircraft is following what is known as a Great Circle route. A Great Circle route is shorter path when traveling over the surface of the spherical Earth and saves time, fuel, and money compared with flying directly east or west. On a flat map, a straight line is the shortest distance between 2 points on the surface of the globe. We can use a piece of string to see for ourselves. Why a trip from the North America to Europe may include an Arctic flyover. In fact, all long distance navigation is rooted in the fact that we live on a sphere. Sailors have this concept to navigate oceans for thousands of years. For decades, airplane pilots and astronauts have done the same in the air. Their livelihood has depended on the Earth being round. Science practice, accepting that the Earth is a sphere, help us understand the world, from 10 time zones to long distance travel. Recognizing and employing scientific proof allow us to seek new and deeper answers. At the same time, exploring a question helps us develop the scientific skills that allow us to go where our own scientific curiosity leads. Also help us to better understand whether or someone else's idea or sound makes sense. Exercising thinking skills make them sharper, just as practicing bass guitar or basketball makes us a better musicians or athletes. Scientific methods give us the means to prove Earth is a sphere. It also helps us develop good questions, explore and expand what we observe, test our questions and observation to see if they help to if analyze. If the answer don't match our hypothesis, we can try again, asking new questions and testing them in different ways. We can trust such properties practice to generate trustworthy answers, then use the answer to propel our curious mind even further.